Welcome back to Remote Sensing Applications using ArcGIS. In this session, we're going to create a hillshade from an elevation raster for the boundary of Denali National Park. So if you go to the Week 2 data, there's a folder called Denali National Park, and there's a shapefile Denali National Park.shp, and that's the boundary of Denali National Park, and that's what we're going to work with. So here's the boundary of Denali National Park. And what we're going to do is use the National Elevation Dataset. So you could go to the National Map Viewer, and you could download National Elevation Dataset from the National Map Viewer. And what we want is a 2 arcsecond elevation dataset for Denali National Park. So the first thing we have to do is figure out what the extent is in terms of longitude and latitude of our study area. So our study area is the boundary of Denali National Park, and what we need to know is what's the longitude and latitude of the lower left-hand corner and the upper right-hand corner. So if you right mouse click on your data frame and go to Properties, and under the General tab, set your display not to meters but to decimal degrees. And then if we point to the lower left-hand corner, down here it's displaying what the decimal degrees are for the lower left-hand corner. So it's about negative 152.6, 64.4, and the upper right-hand corner is about negative 148.6, 64.0. Okay, so what you could do is you could go to the National Map Viewer and download the 2 arcsecond National Elevation Dataset. And if you want to, you could go through that process. And after you go through that process as a registered user, you would get an email from the USGS basically saying, okay, there's tiles of elevation data. In this case, there's 15 tiles or 15 rasters that you would download. So you'd click on these links and download those 15 rasters. So you could do that, but we've already done it for you. So as part as the class data, these 15 tiles are already available. So here are the 15 tiles that came from the USGS via that email announcement. So what you need to do is unzip your 15 tiles, and then we'll load those into ArcMap. Okay, so create a new data frame and name that new data frame Geographic Coordinate System NAD83, and then add those 15 tiles into that new data frame. And this is what they look like. Okay, so if you look at the properties of these tiles, they're rasters, and the cell size is 0.00055, which is the same thing as 2 seconds expressed as in decimal degrees. So if I have 2 seconds divided by 60, that will convert seconds to minutes, and then divide that by 60 to convert minutes to degrees. So 2 seconds is the same thing as 0.000555556 degrees. So that's what the cell size is 2 seconds wide by 2 seconds high. And the pixel depth, there are floating point 32-bit values inside each pixel. Okay, so what we want to do is we've got these 15 tiles. We want to stitch them together into one continuous raster. So to do that, we'll use a tool called Mosaic-New Raster. So we'll search for Mosaic-New Raster, and then we'll use that tool to stitch together these 15 tiles. Okay, so then what we could do is select, so press the Shift key down, select all 15 tiles, and then drag them as our input raster. And then our output location, we'll put them in the Denali National Park folder, and we'll call that elevation geographic coordinate system.tif. And you remember when we looked at the properties, the pixel type is not 8-bit. The pixel type is 32-bit floating point. And then the last thing is the number of bands. So how many pixel values are there inside each pixel? So there's one elevation value inside each pixel. And then my output location will be my Denali National Park folder and elevation geographic coordinate system folder. And then just OK. And that will create a mosaic of these 15 tiles called elevation gcs.tiff. Okay, so now we have a mosaic, and if we check that on, you can see that it covers the extent of our 15 tiles, but now it's basically a seamless mosaic. So we can get rid of our original 15 tiles from our data frame, just right mouse click and remove those original 15 tiles. Okay, so this raster is in longitude and latitude, and our Denali National Park boundary is in the Alaska-Albers coordinate system. So the second step is we'll project this raster so it matches our Denali National Park coordinate system. So that's going to be a tool called Project Raster. So we'll search for that tool. So here it is, Project Raster. So we're going to project our elevation that's in geographic coordinates, and we'll put that in our Denali National Park folder, and we'll call it elevation AK Albers, because that's going to be the coordinate system. So the Alaska Albers coordinate system is a projected coordinate system, and it's in the continental folder. So North America and then the Alaska Albers equal area conic projection. Okay, so then what we need to do is decide our resampling method. Bilinear will take the weighted average of the 4 closest pixels as it resamples pixels. And in this case, let's make our output pixel size an even number. So for example, 50. And then just OK. So then we'll have a raster that's an elevation raster, and it's in the Alaska Albers coordinates, which is in meters, and each pixel will be 50 meters wide by 50 meters high. And we can put that in our original Denali National Park data frame. Okay, so now we've got our elevation raster, and we've got the Denali National Park boundary. The next step is we want to create a hillshade, so we'll use the hillshade tool to do that. And whenever you use the hillshade tool, the elevation raster should be in some projected coordinate system so that it's in linear units such as feet or meters. So hillshade. So our input raster is the elevation that's in the Alaska Albers coordinate system, and our output raster, I'll call it Denali Hillshade. And azimuth is where is the sun in the sky. So 315 would be in the northwest part of the sky, and then altitude is how high it is in the sky. So let's put the sun 25 degrees above the horizon, and then just OK. So that will create a hillshade from our elevation raster. Okay, so now we have our hillshade. And then the final step is we want to cut out the hillshade that's within the boundary of Denali National Park. So to do that, we'll use the clip tool. And there's actually 2 clip tools. One is for clipping points, lines, and polygons, and that's in the analysis toolbox. And then the clip tool for clipping rasters is in the data management toolbox. So we're going to cut out our hillshade, and the output extent will be the same extent as the Denali National Park polygon. So use the input feature for clipping. And then we'll output that, and we'll call that clipped hillshade. And then just OK. Okay, so now we've got our clipped hillshade, and it's within the boundary of Denali National Park. So now we're all set up and we're ready to go for our next video session. So if you go to the Blackboard website and take the quiz from this video session, once you correctly answer that quiz, it will give you the link to the next video session.